So sometimes when we're solving math problems, we can solve them using different methods and still come up with the same answer. And that's kind of what we're seeing in this particular section when we are looking at our homework problem, or one of the homework problems from section 4.4. In the lecture that I did on this section, you'll notice that I solved this equation here, 5 to the x equals 17, and I did it by taking and rewriting the equation out of its exponential form and into its log form. It was a fairly straightforward way to be able to quickly get the exponent, or the variable, out of the exponent position here, and I already had an answer. It was a fairly quick way to do it. So my answer was that x is equal to log base 5 of 17, and the approximation of that value using our calculator is 1.76. Now, in the very next example that I worked in this particular section, I had here where I had bases that were not the same on both sides of the equal sign. And in this particular case, I chose to perform an operation on each side of the equation. So just like I can take the square root of both sides, in this particular case, I took the natural log of both sides. And when we solved that problem, we found that x was equal to this thing down here. It's not a very clean looking answer, but it is in terms of all natural logs, and I could have done it in terms of all log logs, base 10 logs. So it's just a preference for however you would want to solve a problem. In this first one we were talking about at the beginning, in just a moment ago, it was fairly easy to just use the definition of logs to rewrite it. Now, I'm going to solve this problem again, however, and I'm going to do it with that other method. If I were to apply an operation to both sides of the equation here and take the natural log, what would my answer look like then? So let's rewrite this. 5 to the x is equal to 17. And this time, I'm going to take the natural log of both sides and solve it using that method. When we do that, we're going to have the natural log 5 to the x equal to natural log 17. We know from our properties of logs that the x here, which is in this power position, is going to come down, or using the power rule, we're going to bring the x down in front, giving me x times the natural log of 5 is equal to the natural log of 17. Now, since x is what we're solving for, we're going to divide both sides by the natural log of 5. That gives me an answer that looks like the natural log of 17 divided by the natural log of 5. Now, these two solutions, this one here that I worked originally in my lecture video, and this solution here, are actually the same exact answer. If you think back to section 4.3, we talked about the change of base formula. The change of base formula says that anytime I have a log of base anything, I can rewrite it in terms of only base 10 logs or natural logs. And we did that by taking either the base 10, the log, or the natural log. So I would take, let's do the natural log. The natural log of the argument m divided by the natural log of the base b. So the natural log of m over the natural log of b. And you can see that it's the same formula if we use base 10 log. So base 10 log argument m over base 10 log argument b. Now coming back to what we were just looking at here, this is the solution we talked about in the lecture video. Here is another representation of the exact same answer. Notice that it's just, this time we're writing the answer in terms of only natural logs, or it could be written in only terms of log base 10. What did we do? We used the change of base formula. So this time we said that the natural log of the argument divided by the natural log of the base. That was our original answer over here, and this is the same answer represented in that change of base formula. There's no difference in the answers here between the original way that I worked it or this other way that I worked it. Either method works. This method here, where I simply took an exponential equation and rewrote it in terms of its log form, was an easy and quick way for us to solve it because there wasn't a whole lot going on here. I only had one exponent on the left equal to a constant on the right. However, in this example here, I had an exponential expression on the left and a different exponential expression on the right, so I had to apply the natural log operation to both sides. That's really the difference between these two equations here on parts C, or examples C and D. So I hope that helps you understand the differences between the methods that I used versus the lecture, and then also the way that they're maybe asking you to supply the answer in your homework.